So now we get to 21.2, types of angles. We have acute angle and we have obtuse angles. Okay? An acute angle is an angle that is less than 90 degrees. So I will draw one right here. Now, when they get close to being 90 degrees, visually looking at them is kind of hard, but a 90-degree angle, and I'll draw one right here. If you have an angle that is 90 degrees, there should be a marker in there, right there like that, that shows you that that's 90 degrees. So these two lines right here are perpendicular. We've talked about this a little bit before. So an acute angle is one that's less than 90 degrees, and an obtuse angle is one that is greater than 90 degrees. So this angle is greater than 90 degrees. So acute and obtuse. Now we also have what's called a reflex angle. And a reflex angle is an angle that is more than 180. So I kind of drew one right here, but it all depends on what angle in here you're talking about. So let me draw another one, and I'll put it right here. So if I'm talking about this angle right here, that is a reflex angle because it is greater than 180. But if I was talking about the one in here, that's just an obtuse angle. Okay? So it all depends on which one you're referencing to. If the angle you're referencing to is greater than 180, we would call that a reflex angle. Okay? Now, let's go back to up here. Adjacent angles. So two angles are adjacent if they have the same vertex and have a common side. So angle 1 and angle 2 are adjacent angles. So they have to meet those two qualifications. They have to have a common vertex, and they do. D is their common vertex. And they have to share a common side. So let me show you another situation. Maybe we've got angles like that, and then another one out here. Okay? So we'll call this one angle 1, we'll call this one angle 2, and we'll call this one angle 5. And that is the vertex right here. So angle 2 and angle 5 are adjacent angles because they meet the qualifications. They share the same vertex and they have a common side. Angle 1 and angle 5 are not adjacent angles. They do share the same vertex. However, they do not have a common side. So the angles actually have to be next to each other to be called adjacent angles. So let's take a look at figure 21.7. Angle 1 and angle 2 are adjacent angles. Let me see. I'll just draw. Did I have it? That's very similar to this one right here. I'm just trying to save space. That's very similar to this one right here. This angle and this angle are adjacent. So let's draw figure 21.8 and examine whether or not these two angles are adjacent. So let's see, we've got here out to here, and then the other one kind of somewhere in that area right there. So this is angle 3 and angle 4. Now these angles are not adjacent angles. They do have a common side right here, but the vertex for this one is right there, and the vertex for this one is right there. So they do not meet all the qualifications to be an adjacent angle. They do not share the same vertex. Okay? Now, let's take a look at some of the stuff in 21.3. So 21.3, it's first they start talking about a transversal. A transversal line is a line that intersects two or more lines. So if I have a line like this and another one like that, and then one more comes in and it cuts right through there. This line right here is the transversal line. These are the other two lines. Now these aren't necessarily parallel. They don't have to be parallel. All right? So when we talk about things like alternate interior angles, alternate exterior angles, and corresponding angles, we're talking about the two main lines here and then how those angles are related to the transversal. For example, this angle right here and this angle right here are exterior to the parallel, or not, they're not parallel here. They're exterior to these lines right here. They're on the outside. And they are alternate. So one is on one side of the transversal and one is on the other. So these two angles right here are alternate exterior angles. So if I compare this angle to this angle, these two angles are both on the inside. So these angles right here are on different sides of the transversal, so they're alternate, and they're on the inside, so we would call them alternate interior angles. Alternate exterior angles and alternate interior angles. I don't think they mention, nope, they only talk about alternate interior angles on page 549, but their exterior angles are alternate exterior angles as well. Now, corresponding angles. Corresponding angles are both going to be on the same side of the transversal. Wish I had different colors. 1, 2, 3. 1, 2, 3. These angles here are corresponding angles. They're both on the same side of the transversal, and they are, one of them is interior and one of them is exterior, so they're corresponding. Now it's not as apparent, the name of it is not as apparent, it's not as intuitive as alternate interior and alternate exterior, but these are corresponding angles. So looking at page 549 at the very bottom, we have two sets of lines intersected by a transversal. We have figure 21.9 and figure 21.10. So looking at these, well, they don't label all of them on 21.9. So 21.10, let's look at that. Angle 2 and angle 8 are alternate exterior. Angle 4 and angle 6 are alternate interior angles. Angle 1 and angle 5 are corresponding. Angle 3 and angle 7 are also corresponding. Angle 5 and angle 2 are corresponding as well. Now these come into play a little bit more when we get into the theorems and stuff we're going to get into in a moment. But let's take a look at, there, I erased all that quickly. Let's take a look at page 550. And I want to look at the numbers 13 through 18. Now, if I can draw this figure, I would. Yep, something bad happened. I don't know if you heard that or not, but it was pretty loud in here. One of the cats messing around. Okay, so we've got that as angle 6, angle 5, angle 4. And we've got this one as angle 3, and angle 1, and angle 2. And then D, E, B, C, F. I could have probably just brought that over and had the book under, but that's okay. All right, so we've got figure 2112, kind of recreated right here. So it says, name each of the angles in 2 additional ways. Well, there's not always 2 additional ways. So angle 1. So here's angle 1. I can call angle 1, but I can also call it angle ABF. I can call it angle FBA. One thing that I cannot call it is angle B, because it is the vertex of it. However, this angle here and this angle here, angle 1 and angle 2, share the same vertex, so therefore I cannot use that vertex as the name of any angle. So let's see, let's just pick another one. Let's say angle 3. Where's angle 3? So angle 3 right here can be called angle 3, of course. It can also be called angle CBA or angle ABC. Once again, I cannot use the vertex because more angles share that same vertex. So be aware of the different names that an angle can take.